Guys, welcome back. So this is the fourth part of Code April series. I'll be attempting, so I've done week 1, week 2, week 3, and this will be week 4. If you've missed any of that, I'll put a link for you to go watch so you follow through the solutions. We'll start from day 22. Like I said, we've done from day 1 to day 21. If you've missed that, just go back and watch. And remember, the link to this notebook will be in the description box. That links you to my GitHub, so you find the notebook I walked through, so you can also follow through as I'm going through. Focus for day 22 was Introduction to Data Visualization, and the first question is load the MBA data set from day 17. Okay, from day 17, so just load this. So I've already attempted these questions before now, so it's just for you to just me explaining my solutions mainly and just walk you through my solution. So this is the head. Remember what we did when we loaded this MBA data set in week 3. Okay, and so we know that our height was in inches, so just convert was in feet and inches. So now we just want to separate that inches and convert to meters. Okay, the first question is, why is data visualization important in data analysis? I think data visualization is very important because let's say a picture says more than 1,000 words. So whatever you've calculated, whatever you've done, you need to visually represent your analysis so that people can understand. So it helps communication easy. It helps in pattern recognition and help you make decision easily. Okay, so when do you use the line graph? A line graph shows trend. When you have trend, you want to see how things changes over time, you want to use the line graph, and they are ideal for visualizing progression of your data sets. Okay, the third question for day 22 was to explain the basic steps involved in creating a plot using Matplotlib. So the first thing, you want to import your Matplotlib package using the import as pyplot. So you're importing matplotlib.pyplot as PLT. You create your figure, your axis, and you plot your data. Then you can save your data. But that's just like a summary. So let's go more in details. Question 4, say visualize the distribution of height, age, and weight using histogram. So histogram should help you show distribution of data. So you could say, okay, I want to visualize my height. So I think what a lot of people did, people that attempted the code April, they used the original height column. So if we use height, for example, as it came with the data, you won't really get a good distribution because the data is not integer. It's in string format, so you wouldn't get. Okay, I need to import this. Sorry. So if I use the original data as it comes, I may not get good distribution of data. So it doesn't really tell anything meaningful. But if I convert that to meter, so you can really see the distribution. So you can increase, for example, I can increase beans to, let's say let's make it beans to 15. So I want to just get it more finely. So it just depends. You can adjust that to suit whatever you want. So within this, what this can show, you can see from this is you have more players with between, let's say, 2.0 some to less than between 0.2 to 2.1 meter in height. You have more players, about over 100% of your player, over 100 of your players have about 2.0 something meters. Then also you want to sort the same thing for age. I want to say what is the distribution of age in my data. So most of my players would be within 22 to 25 years of age. So I can also increase the bins to, let's say, 15. So let's see, let's just get more detail. So yeah, this just shows the distribution. So the same thing for height, for our weight now. So we have most of our, so remember this is in pounds. So most of the players within 220 to 250 pounds weight. So now let's calculate. So the next question says, question 5 says, using the bar chart and visualize the salary of the top 15 players with the highest salary. Okay, what's the top 15 players? So all you need to do is sort by salary. So I just want to get so let's break it. So when you don't understand, so when you see a complex code, you want to break it down to see different, just break it in parts. So first of all, I want to sort, let me make this. I want to sort the salary. So I just want to get the name and the salary. So I want to sort in ascending order. So from the in descending order, so from the highest to the lowest. and head 15 just say give me the first top 15. So these are the top 15. So I can just create a bar chart to see who are the top 15 players earners in my data. So I can increase. So I can increase the. I want to increase the size of this. I can do pl.figure. I can say fixed size. Fixed size is equals to, let me make it 15.7. Let's see. So the width and the height. So we have Kobe Bryant as the top the highest earner, the top the top salary. So now, I want to calculate the total salary for each team. So I want to see. So we have different teams in the data. If you remember what we did for the so let's see, NBA DF. I want to get the team. I want to get the team, right? Okay, team. I want to get the unique. Unique. So how many all the teams I have? We have a lot of teams. Let's say if we use n unique, let me do this. If I use n unique to see how many unique teams I have 30 teams. So I just want to get the top what was the question now? Get the top salary for each team. So for the team, so let's see. Okay, this just plots everything for us. Let's see. This the team with the highest salary. So from this, the team with the highest total salary is the Cleveland Cavalier, whatever that sounds like. But this just shows you, with this you can now start saying which team has the highest salary and which team has the lowest salary. Yeah, then you can see identify the top colleges represented by the data. So I want to count all the colleges. For example, I have different colleges represented in my data. So let's do that. Let's see, let's break it down. So we have different colleges. So I want to get the top 20 colleges. So for example, these are all the colleges with the highest number of players in the data frame we got. So with this, you can already see, for example, Kentucky has the highest number of players within the data set we have. So this just shows you the difference. So we have this by age. I can do the normal bar, so I don't have to do by age. This is horizontal. It just depends on what you want to see, and that's what you. Okay, so I need to run this. Okay, so I just want to run this to see. Okay, so the same thing. So it depends on how you want to view it. So Kentucky followed by Duke and Kansas College. So there are other visualizations you can do as well. I can plot, let me say, the distribution of the height in inches. So I don't think this makes for anything. So I can make this in meter. No, I don't think that's correct. Okay, let's see, height in meter. So you can change the color. So edge color, you see that they are all black, change to sky blue. So it depends. So you can customize your chart as you like, depending on what you want to see. In this case, I've changed it to red and things like that. Okay, the next question is, okay, let's see, calculate the average point. So we have a column called point. What's the average point for each of the players? Yeah. I think at this part I don't need. In this case, you can also visualize the team points for each of the team. So for the team, how many points do they have in total? So the Boston had the highest points for each of the total points together. So you could also look at the colleges with the number of players. I think we've done something like this before. So now day 23. So we've done 22. Day 23 was focused on advanced plotting and customizing. So we want to start customizing our plots. So you add labels. So we'll explain the significance of adding labels, title, and legend. It's more explaining your data so that people understand what you see. If you see different colors, different axes, you want to understand the title, the label, the x-axis. So just gives better explanation to your code. Oh yes. Okay. So now question is to create a pie chart to show the proportion of the different positions in the data set. So we have different positions. So I want to see how many, what's the proportion in the data set. So if I run this, just do your plt.py. You can just quickly plot, use a plt.py, put the title, But you can now start customizing this better. So let's see, let's just copy this out. So if I say .py, but I want to make this so the label position, I want to put the label as index, I want to put the percentage and just different things in general. You can take out some of these things to see what they do and what they don't do. So this is this, you can see the positions of your thing. So with this, you can just plot to see the different positions, see how you start customizing your pie chart. With this, you can see that we have the SG as the highest position. Then you could also create scatter plot to visualize relationship between player height and weight. So just plot and PLT to scatter different things. So the same thing, so you just go scatter of weight and height. I think we have the same thing. In this case, we are adding grid. So in this case, we didn't have grid. So just as how you start customizing your charts. So you want to see the relationship between player number and salary. Let's see, you can see how they are distributed, different clusters. So now I want to create the next question. Say create a subplot of 3 rows and 3 columns, 2 rows and 3 columns, and plot different things there. So I've already done this, so you can study this. So all the plots we've plotted before, I just want to add them to my subplot. Again, if you don't understand how to create subplot, I have a video on my channel that explains subplot, anatomy of a matplotlib figure. I'll put a link for you to go watch it there. But yeah, this is how I've created all this. Then so when you run that, it's quite a lengthy code. I don't want to say it's just about me bringing all the plots we've done before now and putting them here. So now we have this beautiful plot with all our different charts in one figure. Yeah, so let's go to day 24, the final day before the project. So say create a scatter plot. So in this case, with data visualization, there are different libraries you can use for data visualization. Matplotlib. Another good plot is the Seaborn. So everything we've done before, we can do the same with Seaborn. Okay, so let's just plot all to replicate all our plots using Seaborn. Okay. Replicate the plot using Seaborn. So okay, let's just do this. I don't know. Yeah, so you want to create your bar plot. So different bar plots we've done before. Want to use it. Okay, this is the Seaborn version. So again, you could just go study these different codes so that you understand how these are all created. So we can also create the so in this case, we want to create a subplot of the distribution of the height, so the histogram of height. So in this case, before now we used matplotlib. In this case, we're using Seaborn. Okay, so you have that. So you could also one good thing I like about Seaborn is also creating box plots. So there are different plots that shows distribution of data. So you have your histogram, you have box plot, you have limb plot. All these plots shows your data distribution where you have so I could put a link also for you to just understand what a box plot means, where your data, you'll see your outliers. So if you're doing outlier analysis, all the circles would be considered an outlier in the data, but your data, so where you have the main box is where the data itself is concentrated, where you have data concentrated. You have your minimum, you have your maximum, your mean and median, things like that. So we also create a volume plot using the ages, so the position and their ages. In this case, we did their position and their salary. So they kind of tells you the same thing, more like where your data is concentrated. You have your mean, maximum and minimum, things like that. Okay, so you could also do your kernel density estimate just to show the distribution of your data. So for weight and density, so for example, but we did this by position. So the weight of people in PG, for example, is within 150 to 225. So it just shows you the distribution based on the different position. By this, you can already see. So for example, you want to play in a particular position, you already understand what weights and brackets do I need to fall in for me to be able to play. So this just shows different distribution. You could also do a pair plot with Seaborn just to show distribution. For example, let's say age and height. You see the different age and height are separated by position. So you could start studying different correlation between different variables and using the position. In this case, we're using position as as the differentiator. Okay, so also say create a heat map using Seaborn to visualize correlation. So when we did, I think one of the days, I can't remember the day in particular, we did correlation coefficient. So with your heat map, you can show how correlatable, so rather than just trying to make sense out of figures, you can just create a visuals. So you can see in this case you have the highest, the very light red shows very positive correlation, and the deep blue shows negative correlation. So you want to see, or for example, height and weight, you have high correlation between your height and weight. You expect that, right? Okay, and there are other things you can do. So you can customize, change your color, things like that. You can change the background color. These are some things you can also explore. Yes, okay. And these are just different kind of chart. I like this chart. I don't know what it means, but I kind of liked it. So you can see within salary and weight, you can see how the distribution goes. For example, the captains, like, see, they have higher salary, and they tend to weigh more compared to, let's say, the PG. Or so you just see, if you plot this as I think I plotted this as scatter, but it wasn't making. But I love the way this web plot came out. You see, at least you can really see how the different positions differentiate based on their salary and their weight. You see, okay, for example, you want to go play in the NBA, for example, because of if your focus is money, you want to target to be a captain, to be the top earner within a particular team. So this brings me to the end of Code April exercises. So I mentioned earlier that I was going to divide it into 6 series. So we've done all the exercises for Code April. So in the next 2 videos, I'll be attempting the projects I gave. So there was a Titanic data project and also an airline data set analysis also. So in the next videos, I'll be attempting those projects. The link to the notebook would be in the description. Make sure you go download it so that you follow through.